All right, so now we're finishing up our ellipse and completing the square. So this is the format they're giving us. It's not in that perfect form that we had before. So the first thing you want to do is just like the circles, you want to move that number that does not have an x or y to the other side. And then put the x's together and the y's together. And then what we're going to do is whatever number is in front of the x squared. You don't get to pick or choose a common factor. It literally is whatever number it is, and you factor it out. So we want to take that out, and then we check 9x squared plus 18x works perfect. And so this number right here is going to be what we use to complete that square. And we use the same thing we did before. So we're going to take half this number. So half of 2 is 1, and then we're going to square it. But if you add 1 to one side, you have to add 1 to the other. Now here's the difference. With an ellipse, there's a number in front. With a circle, there isn't, because you could divide it away. But there's a 9 here. And so over here, there has to also be a 9. So I'm not adding 1 to both sides. I'm adding 9 to both sides. So I've got to put a 1 here. So when you take that factored 9 out, you want to put it on the other side as well. All right, now let's move on to the next one. So the same thing, half of the negative 2 would be negative 1. And then we square it. And if you always notice that this is always a positive there, because we're squaring it every time. So then it'd be 4 times 1 again, like this. Okay, so simplifying this, we get 9 plus 4 is 13 plus 23 is 36. And then now we just need to finish it. I'm going to change that to black. So now if we divide everything by 36, we end up with x plus 1 squared over 4 plus y minus 1 squared over 9 equals 1. And we have our nice perfect circle, or ellipse, with a center of negative 1, 1, and we're going to go 2 units in the x and 3 units in the y. Okay, so let's do this same thing now, but without any help. So we sort x's with x's, y's with y's, and we put the 29 on the other side and change its sign. Now we factor. So the first one, there's nothing to factor. We can leave it alone. So we just need to complete that one square. The second one, we factor out the 2. And there we go. So now we know we're going to add 1 times something for the first one and 2 times something for the second one. So this is whatever I put here will just be 1 times it, and whatever I put for the y's will just be 2 times it. All right, so now let's finish this up. So we need to complete our square and get our nice clean formula. So this would be x, and half of 10 is 5, and 5 squared is 25. So we're going to add 25 to that. So far that's negative 4. And then bring down the 2. And then half of 4 is 2, and 2 squared is 4. So we put 4 there. So that would give us 8, and then 25 and 29, so that's 4. And so now all we have to do is divide everything by 4. And so that would end up with an equation of x minus 5 squared over 4 plus y plus 2 squared over 2 equals 1. And there you go. So now to graph it, we know we're centered at 5 comma negative 2. So 1, 2, 3, 4, 5, and then down 2. And then we're going to move square root of 4, so 2x left and right. And square root of 2, which is 1.41, up and down. And so we end up with that. And yeah, you can move square root of 2. It's just an approximation of our values. And then you get your football. That's what they always look like for me. All right, so now we're going to check this in the TI calculator. So I've plugged it into Desmos, and there's our ellipse, and you can see there's 3, negative 2. There's 7, negative 2. And there's our 5, negative 0.5. So it's that 1.41 right up to there. So you can see that 0.5 right here. So there you go. And there you go. It looks perfect. All right, so let's try it one more time just to get another example. These take practice. So again, we sort our x's. Leave a space. I'm going to zoom in. Sort our y's. and then move the 11 on the other side. And again, we factor out that 4 because it needs to be x squared. And we leave our space. Factor out the 9. And then verify because I already made a mistake. So it's 4x squared, 16x, 9y squared plus 18y equals positive 11. Works perfect. All right. So now we put our little parentheses and we do half and square. So half of negative 2 would be 2, and 2 squared is 4. And so I put over here plus 4 parenthesis 4. That's how it looks here. It's a 4 with a parenthesis 4. And we bring down our 4. And then it's 9 parenthesis. And then y plus half of 2 is 1, and 1 squared is 1. So that would be 9 parenthesis 1, just like that. And so we end up with 9, and that's 20. And 16 is 36. So now if we divide everything by 36, we get x minus 2 squared all over 9 plus y plus 1, I forgot the square, over 4 equals 1. So our center would be to negative 1. And then we're going to go 3 and 3. 3 and 2. So 2, negative 1, 3 in the x, 2 in the y, and we draw our football. All right, let's verify this one as well in Desmos. So I've plugged it in, and you can see that center of 2, negative 1, and then it's up 2, down 2, left 3, right 3, checks perfect. All right, so the last one is yours to do. So I want you to complete the square with it and graph it. I'll give you a hint here. Your y squared is already ready to go. There is no shifting for the y. So you can leave it alone. All you have to do is the x. So it's a good warm-up problem. So hit pause now and give it a try. So there's your graph, and that was a really messy looking one, but you should have gotten this for your final equation right here. And so that's centered at negative 3, 0. And to graph it, you just approximate. So square root of 10, square root of 45, which is 3 rad 5. But you get this. And then you plug it into Desmos to verify, and you can see these are the values. There's our negative 3, 0 center, up the 6.71 and down 6.71. It checks perfectly. All right, there are other things we did not mention, which are foci, which we can use to graph a much nicer perfect graph without graph paper, using a pencil and a string. So you can find it using your a squared minus b squared, and this is a is bigger. And if b is bigger, then you do b squared minus a squared to make sure that this stays real. But that would give you your locations of your c, okay? The distance that is from that center. You would go c units left and c units right. But what they represent is every single point on this ellipse is equidistant from these 2 points. So if you were to take that sum and add it up, that point would have the same sum from that focus to that focus as if I went over here. So any point you pick on it, its distance from those 2 points together, the sum of them, is the same. So it's like if you put a string on there and you use that string in your pencil to go around, it would give you a perfect ellipse every single time because the distance is the same from these 2 points. And these 2 points would be your foci. And the c would be the distance from the center of them. And that's it. Thank you.